Hi all, Dr. Clark again, Natural Resources, lecture number 2. Today we're going to talk about global issues. Okay, some of the things that are going on in the world that an environmental scientist or a natural resource manager might be interested in or concerned with. Okay, so let's start off by looking at something so simple yet so telling. Okay, and that is the human population. Okay? So if you look at the human population today, okay, give or take maybe a few hundred people, okay, so I pulled this data on 8/26/18. There's 7.6 billion people on the planet. Okay? So if you think about that, and let's just say, you're a student in natural resources, let's say you're straight out of high school, you're 18 years old or so, okay? When you were born, let's say you were born, this month, okay? When you were born, there's only 6 billion people, okay? And if we start dropping 10 years back from when you were born, okay, to 1990, 5 billion people, 80, 4 billion people, 70, 3 billion people, 60, 3 billion people, okay? So many of you know lots of people that were born in the 60s, okay? Lots of you who might be 18 years old, your parents were born probably somewhere in the 70s or 60s, maybe into the 80s, but still, nonetheless, the world had half the population when your parents were born. Okay? And for some of the older students that are in the course, okay, when we were born, okay, maybe even closer to 2 billion people. Okay? Maybe a quarter of the world's population, okay, that currently exists today. Okay? Now that might be concerning or it might not be concerning. And we're going to look at how this might affect world issues today. Okay? We can put it in a different perspective. Okay? If we look at from 1804 to 2011, we went from 1 billion people on the planet to 7 billion people on the planet. It took 207 years. Okay? To go from 0.2 billion people to 1 billion people, it took us 1,803 years. Okay? So in 1804 we hit 1 billion. Okay? But literally 200 years later we hit 7 billion people. Okay? Now the reason why I bring that up, okay, is not because I hate people, okay? And I don't like to go to a national park and have it crowded. I don't like that. Most people don't. Okay? I don't like to go to Disneyland and wait in line. This is true also. Okay? But that's not why I bring it up. There's a lot of real world issues that are connected to human populations. Okay? So we can start looking at some of these. For example, if we plot the human population in millions, okay? Over here on the right axis is the human population in millions, okay? And that's that purple line going up. And then if we plot the number of known extinctions, okay? So these are extinctions of any organism, any species on the planet that we know of. Okay? And you plot that over here on the left axis, look at those figures. It's hard to argue that as the world's human population increases, that we're not having a direct effect on the extinction rate. Sure, some people might say, well, as the human population increases, we have more eyes and we know about more species. Okay? That might be true. Okay? So we're better at documenting extinctions. That's probably part of this. That might be absolutely true. But I highly doubt anyone would argue that going from 1950, where we had roughly 2 billion people, to the year 2011 or so, where we have 7 billion people, would also cause, that much of a drastic increase in extinction rate. Were there really that many more scientists between 1950 and 2011? I mean, the scientific community hasn't increased nearly as fast as the human population, right? There's actually probably less ecologists now because there's less jobs for ecologists now. And you have a limited number of jobs in the field of ecology. And these are the individuals that would be, documenting extinction rates and whatnot. But let's say that part of it is that, okay? Then when we look at a graph like this, okay, is it also because we're better at detecting CO2 emissions? I don't think so. Our technology in the 1970s and 80s was probably just as good as it is today at collecting CO2 emissions. Yeah, we've been collecting CO2 emissions the same way for a long time. And you can see the exact same trend. As population of humans increases, so do CO2 emissions. Okay? Now, I'm not saying that that's necessarily a bad thing. Okay? But when you add extinction, CO2 emissions, and we look at another one, here's the population of humans increasing. Okay, population of humans increase the exact same way on all these graphs, okay, because that's data that's been collected. Okay? Now, some of the graphs are just different years. Like this shows 2010. We haven't made it to 2011. That's where we actually hit the 7 billion mark. But you can see this red line here. This is how many billions of hectares of forest have been cut down or deforested. So you can see CO2 emissions is going up with human population. Extinction rate is going up with human population. Deforestation rate is going up with human population. Okay? It's not all a coincidence of better data collection. Okay? It's actually occurring. Okay? So, what does it mean, though? Well, it can have some effects, some major effects. We know what forests do for the environment. We know what increases in CO2 due to the atmosphere. And we can start looking at, other trends that are going on. Okay? Climate change. Okay? Now, for some people, this is a bad word. Okay? But it's not a bad word, and you really, truly have to be to the point where you cannot read a thermometer to say that the temperature on the planet is not increasing. If you look at a graph, okay, and why would Noah make this up? Okay, there's no reason to make the data up. Okay? If you look at the graph, okay, of temperature over the last 100 years or so, okay, if you look at that, okay, and you look from 1980 on, okay, we still had thermometers way back here, and we had thermometers way back here. So it's not a point of having thermometers or a point of being able to calculate 1/10 of a degree. Okay, we could do that in this era also, and we did. Okay, what we are starting to see though is you get a bunch of years stacking. Right, very warm years. Now, students have asked me, well, couldn't this just be cyclic change? Absolutely. It definitely could be a cycle. Okay? But what scientists are saying is, if this is a cycle, it's like no cycle we've seen before when we look at the past. Okay? It came on and is coming on much faster than any cycle we've ever been able to record. Okay? And regardless of if it's just a cycle, we still need to try to maybe not do something about it, but be prepared for what might occur because of it. Okay? We've seen the temperature on the planet warm before. Okay? Well, we haven't personally seen it. Okay? Okay? But we can document when it has. Okay? When ice ages occurred 15,000 years ago, and then they warmed up, we know what has occurred because of that. The oceans rose. Their levels rose up. Okay? And they rose up maybe by 3, 4, 5, 10 feet. So what does it mean when we talk about beachfront houses or buildings that are close to the ocean? Probably means that we should have never built them there. Okay? Now, I'm not saying that these places will be flooded out, but all you have to do is do like a general Google search on how many homes have been flooded out near oceans, and how much oceanfront property has been removed due to within the last 20 years or so. It's a great deal of property that's being chunked away, eaten away. Okay? Now, is humans the cause? Who knows? Okay? It seems like the trend is to increase with everything else. Deforestation. Humans are definitely the cause of deforestation. Okay? Extinction, you could say that humans, because they deforest, they're also the cause of a lot of the extinction going on, and especially when I'll show you, what's going on in certain countries. Okay? Carbon emission, well, yeah, humans are the cause of that, okay, because we're burning what we would consider ancient carbon sinks. So coal, oil, and natural gas, that's all carbon, and when you dig it up out of the ground, okay, so again, it takes about 350 million years or so for plant material to turn into oil or coal or natural gas, depending on what the pressure is and the soil type and the rock that it's embedded in and the temperature and things like that, on what it might come into. And we'll get to this later on. Okay, about 350 million years. Okay? It takes about that long, and you have to assume, though, because of all that material has been dead for that long, and then you're bringing it up and you're burning it, that you're definitely going to release carbon dioxide or monoxide. Okay? You're releasing carbon back into the atmosphere. Okay? Ancient carbon, stuff that's been stored for 350 million years. Okay? Now, does that have a direct relationship with temperature? Most climate scientists say yes. Okay? Now, does that mean that we cause the temperature to warm and we're the only cause for the temperature to warm? I don't think so. Okay? The temperature might be warming on its own, and we're just helping the rate increase a little bit. Okay? But we'll get to this. We'll look more at the climate science at a later date. I'm just throwing this out there, what world conditions we are facing, okay, as a nation and as the global population of 7.6 billion people. What are we facing today? Okay. So the other thing about warmest temperatures I should point out, so if right here this map is showing that 2016 was the warmest temperature, okay, warmest year on record. Okay, it still is the warmest year on record. Okay? 2017 was the third warmest year on record, and 2018 is not quite done, but most of the results look like 2018 will be in the top 5. Okay, so if you have 2016, 2017, and 2018 all being in the top 5 ever recorded, okay, since 1880, okay, it might be something to look at. It might be a concern. Okay? Maybe not, though. Okay? But there are some things that are definite concerns, okay? Like hunger. Okay? So if we look at hunger, and we're actually improving on hunger, okay? Or improving on the number of individuals that are undernourished. So this figure here shows that in 1990 we are almost at 1 billion people, or we're 991 million people were faced with undernourishment. That trend is starting to go down. Okay, it's not going down as fast as a lot of people want it to go down. Okay, but it's starting to go down. So, and today we're at about 10% undernourished in the world. But think about that. 10% of 7.7 billion or 7.6 billion is 760 or 770 million people are undernourished in the world. This is a huge deal. Especially when you put that into perspective in the country that we live in. Okay? So if you're watching this from another country, I'm talking about the United States. Okay? The United States of America has 350 million people. That's it. We are the third largest country on the planet. Okay? But we only have 350 million people. So if you take that and you took every single person in the United States and you doubled them, and then you add a few more, that's how many people in the world are undernourished and basically dying of starvation. Okay? So that's the perspective I want you guys to take when we talk about things in class. If you compare it to 350 million or the entire population of the United States, that's a big deal. To take every single person in the United States, make them all undernourished, okay? And then take, all of Canada and all of Mexico and make all of them undernourished, and then you still have to bring in a little bit more from other countries, okay? And that's a massive amount of the population that's undernourished. Okay? Clean water. Okay? So another world issue that we're dealing with. Okay? About 780 million people do not have any access to clean water. Okay? So the water that they have access to is not palatable unless they do something about it. So, boil it, okay, and then strain it, okay, and maybe boil it again. And there's lots of ways at which they can make their water source somewhat clean, okay? But we're talking about a huge amount of people that have no access to clean water. Okay? So they can't just open a tap, drink the water, or go to a stream, drink the water, anything like that. It's, lots of people. Okay? But more concerning is, why are those 780 million people without clean water? Well, part of the reason is there are about 2.5 billion people on the planet. Okay, remember, there's only 7.6 billion people. Okay, so 2.5 of them lack proper sanitation. Okay? That means either sewage is moving straight into the water system, into rivers and streams and creeks without filtration. There is no sewage, so defecation and other acts are happening inside the river or next to the river, or in the water system or on land, and it runs into the water system. Clothing, okay, these kind of things are being washed. Soiled clothing, or and other things are being washed in water systems. So sanitation is a huge deal, throughout the world. Okay? Even in parts of the United States, proper sanitation, it can be a big deal. Okay? So I got another piece of material for you to watch. Okay? Blue Gold is a video about some of these issues with water, okay, and the issues with individuals who make money off of water, but also individuals who just don't have clean water, okay, and huge populations that have no access to clean water, and in some cases the wars that are going to be fought over clean water or any kind of water. Now, again, you might have learned from an environmental science class, a bio class, just a general class that maybe you took in high school or even elementary school maybe, that the amount of water on the planet today is the same amount of water that was on the planet 4.6 billion years ago when the planet came into existence. This is true. So next time you're drinking a glass of water, you could be drinking molecules of water that a dinosaur drank. But the problem is not that we don't have water. The water's not going away, but the water's not clean. So the access to clean water is gone. It's so polluted, okay, that there's no access to 780 million people of any kind of water source that would be palatable. Okay? So you can check that out. There's the YouTube, okay, for it. Otherwise, you can just Google or YouTube blue gold. If you want to watch the video, I'll put an Amazon link to it. So if you want to buy the video, it's an excellent video that talks about lots of situations that are going on with water. Okay, now water is a fairly important resource in most people's eyes. It's the most important resource, and that's why when we are trying to find life on other planets, one of the key pieces is we're trying to find water, because as we know it, life can't exist without water. Okay, so when we're searching around and we're talking about different types of moons and they have an ice cap and potentially liquid water underneath that, okay, we get really excited about that because there could be life in that water underneath. Okay? So check the video out. I think you'll enjoy it. It might make you sad to learn about some of the things, but like I said before, the truth will set you free, but sometimes it will piss you off. Energy. Okay? Energy is a world issue. Okay? And it's starting to become a very big world issue. Okay? If you take what the World Coal Association says, okay, this is according to them, that we have about 150 years left at the current rate of consumption for coal. 150 years for coal. I think most of you have met someone that's 100 years old, okay? Or at least close to it. 150 years from now, according to the World Coal Association, we will be out of coal, gone. Okay? According to that coal association, we got about 50 to 55 years left of oil and gas. Now, the caveat to this is they're talking about what we know about. Okay? 150 years, current rate, okay? 50, 55 years, current rate of what we know about. Okay? Now, that's not to say that we don't have, deposits that we haven't found. But I assure you that maybe we could double each one of these. Okay? Possibly triple each one of these. Okay? But at some point in time, okay, even if you could, times each one of these by 10 times, because we're going to start exploring the ocean and removing materials from the ocean, and we find out better ways to do that, you're still going to run out. We're still going to run out of coal and oil because we do not have 350 million years to wait for more coal and oil to become deposited. Okay? So, okay, whether the human population likes it or not, okay, we are switching. Okay? And either we switch in a nice, steady manner, or we'll be forced to switch extremely fast and we'll make a lot of mistakes probably. Okay? So as we switch from carbon-based fuels, so coal, natural gas, oil, and we go to more renewable-based fuels, okay? Whether that be wind or solar or water or, other things that are potential out there. Okay? There are going to be some growing pains, that's true. Okay? But really, our hand will be forced eventually to make that switch. Okay? Now, let's say we times that by 10. Let's say we actually have 1,000 years left, okay, of both. Okay? The sun itself is not expected to increase in power. Okay? So what's happening is the sun is going to eventually become a superstar. Okay? It's not expected to do that based on physics. Okay? For roughly 1.5 billion to 3 billion years from now. Okay? It won't make it to a point where our water on the planet starts vaporizing. Okay? So when we start talking about renewable resources like wind, water, solar, okay, the life expectancy of those is in billions of years. Okay? Now, I don't have any stake in this. I don't own any stocks in any markets or anything like that. I'm just presenting you what has been reported, okay? And what is reported, scientifically reported out there. Okay? Biodiversity loss. Okay? In 2014, Pem et al. Wrote a paper about species loss on this planet. Okay? And estimated, it really depends on the region you're from, okay, but estimated that every single year we lose in between 100 and 1,000 species. Okay. So if you look at this, and we look at species loss, okay, and we look at where we're losing the majority of species or where we've lost them thus far, okay, United States, okay, we've lost roughly 259 species in recent times. Okay, over really the last 5 years, we've lost about 259 species. Now, take this in perspective, because this organization, okay, the Red List organization, they don't consider things like bacteria, archaea. Okay? They don't consider protista. Rarely are any fungi listed as endangered, okay, or critically endangered, or even gone extinct. So for the major kingdoms, they don't even get listed. Okay? So when we talk about species loss, okay, 1,000 species per year, we're not talking about losing 1,000 mammal species. Well, there's only 4,000 on the planet, so that wouldn't make much sense. Or 1,000 plant species. We're talking about losing thousands of species of bacteria, protozoans, potentially fungi, archaea. Okay, we're losing species, a lot of species we've never discovered. Well, the importance of that really comes into, often people will say, well, what good are they? Well, the majority of our medicines and pharmaceutical things come from plants, and we can synthetically take them from bacteria, right? Potentially protozoans, depending on the type of protozoan. We have a lot to learn from a lot of these organisms that are going extinct. Okay? So the United States hasn't done a very good job, okay, at protecting species. Okay? Now, does that mean that we're not doing a good job now? I would argue actually we're doing one of the better jobs now. We've already lost a massive amount of species, and now we're starting to be more mindful of that. Okay? Other countries that are trying to increase their status in the world are not being as mindful. And so you start seeing species loss increase in India and in China. Okay? And they're starting to have a lot more species extinction increase. Okay? Brazil is increasing. Okay? Some of the countries that are trying to, I don't want to say catch the United States, but they want to be at the same level as the United States. Okay? they're losing a lot of species every year. Okay? Air pollution. Okay? This will put another perspective on the whole carbon dioxide, okay, carbon monoxide issue. Okay? So the World Health Organization in 2016 published a piece of literature that said anything that is 10 micrograms or less per cubic meter is safe enough for people to breathe. Okay? Bakersfield, California is at 18.2. So under the World Health Organization, they would suggest this is their average, okay, Bakersfield's average. Okay? Now some days it's way under 10, some days it might be much over 18, but they would suggest that you do not travel outside of your house when anything becomes over 10 micrograms per cubic meter. Okay? Bakersfield on average is higher than that. Okay? People are still traveling out, but they've seen real world health problems with things above 10 micrograms per cubic meter. Let's look at the world though. This is scary. Right? At least scares me if I was to live in one of these other countries. Those are the 20 worst cities for air pollution. Look, in Nigeria, 594 micrograms per cubic meter. 38 times what you would find in Bakersfield, California. Now, if you look down this list, you're going to see a lot of places that have a lot of people. China, India, okay? Those regions of the world are the most populated places on the planet. Okay? China and India are fighting for the most populated place, and they each have over 1 billion people. But they also have some of the worst air pollution. Okay? So when we're talking about the overall health of the world, these should be pretty concerning for most people. When we're talking about places that you might go and visit, okay, that are 30 times higher than a city, the worst city in the United States. Does that mean that the United States is doing things right? Well, when it comes to air pollution, we are doing a much better job at it. Okay? People aren't burning plastics. Okay? People are trying to carpool, okay? Cut down on the amount of carbon dioxide that are coming off plants and things like that. We have carbon scrubbers and other policies that are in place. Okay? But still, even that, okay? We have a number of cities. Okay? Bakersfield is not the only one. I don't want to pick on Bakersfield, California. We have a number of cities that are above 10 on average micrograms per cubic meter per year, okay? Which would be concerning to most people. Okay? All right, so that brings me to the 4 environmental stages. Okay? First one, pragmatic resource conservation. Okay? The second one is moral or aesthetic nature preservation. Okay, so this is conservation versus preservation. We'll get into this in the next lecture. Okay. Then we have kind of a more modern approach, and that's concerning about health, whether that be clean water, clean air, these kind of things. And then what about the ecological damage that's going on? Okay. And the final one is not looking at self. So really, we first took a look at ourselves, the United States, tried to fix our problems, which you can tell, which seems like we're moving in the right direction. And now we have a moral kind of right or moral expectation to fight and help the global environmental citizenship. So what's that global piece that we can do? Okay. So I'm going to stop there, and we'll pick up and we'll talk about these 4 environmental stages, okay, at a later date. Peace.